Hello and welcome. My name is Regina Sampson, Accreditation Program Manager with IEEE Educational Activities. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Before we begin, please note a few housekeeping items. At the bottom of your screen are engagement tools you can use. All tools are resizable and movable, so feel free to move them around to make the most out of your space. Note that we recommend using a wired internet connection to access today's presentation and closing any programs or browser sessions running in the background that could cause issues. There is no dial-in number for this event. Please make sure your computer speakers or headset are turned on and the volume is up so that you can hear our presenters. You can find additional answers to some common technical issues in the orange question mark help tool at the bottom of your screen. If you have any questions for today's presenters, you can submit them through the Q&A widget on your screen or click the purple Q&A icon at the bottom of the screen. We will answer as many questions as time allows. If you click the green resources icon at the bottom of your screen, you'll find more information about today's events and future events. Finally, the on-demand link for today's event will be emailed to all registrants approximately 2 hours after today's session. Our virtual event today is IEEE's TryEngineering Tuesday, Aerospace Engineering. TryEngineering.org inspires the engineers of tomorrow and empowers educators to foster the next generation of technology innovators by making it easy to bring engineering into the classroom. If you would like to tweet about this event, please use the hashtag TryEngineering. At this time, I'd like to hand it over to Lynn Bowlby.
Thank you, Regina. Hello, everyone. Thank you for joining us today. My name is Lynn Bowlby, and we'll start our session today with a little quick poll. We'd like to understand who's participating in our session today. I'm going to move forward, and you'll see some options to select. If you could just let us know what your current role is, whether that be a volunteer, a parent, an educator, or a student. Give you about 15 or 30 seconds to answer that, and we'll move forward and see the results. Okay, I'm going to move forward there. Okay, so looking at the results, we have some university educators with us today, as well as students, and we also have engineers. So thank you very much for joining us for today's session. Before we get started, I'd like to introduce to you our speakers for today. We're very happy to have Francesca Filippini with us from the AESS Board of Governors, and Walt Downing, who is the president of our AESS Society with IEEE. So thank you, Walt and Francesca, for joining us today. I will also serve as a speaker, and Donna Schultz, who is our Senior STEM Education Outreach Program Manager. So Donna, thanks for joining us. So we'll get started with giving you an overview of a new resource that we have available through our TryEngineering website called TryEngineering Tuesday. And in just a moment, I'll share my screen and show you a live view of what the TryEngineering Tuesday blog looks like for this month. So the blog will include 4 steps. Step 1 is Explore, which will provide some career connection. Step 2 is Discover, where you'll find hands-on activities. Step 3 is Inspire, and these will be opportunities to make a difference. And step 4 is we would like you to share anything that you're doing out there where you're using the resources from TryEngineering Tuesday or lesson plans or other resources from the website using hashtag TryEngineering Tuesday. Now let me share the live version of the blog with you, just one moment, and then we'll get started interviewing our guests for today. Okay, here we are. So we're going to start today's session speaking a little bit about our Explore section. So you'll see step 1 is here on the website. And Walt, let me just give a little, before I get you started, Walt's going to be the first one to answer some questions with us today. So this month, we're going to blast off into the engineering world of air and space. So aerospace engineering is a launching point for people who want to design and build vehicles that fly. So today we're going to speak with our 2 engineers, Francesca and Walt, who work in aerospace engineering. Walt, can you give us a glimpse into what you do in your job?
Well, thank you. Lynn, what I'd like to do actually is just give a brief glimpse of what I've done over my career, because, as an engineer, you can do almost anything. My career started out actually as a cooperative education student way back in the late 1960s and early 70s, where my co-op assignments were for the U.S. Air Force. Co-op is where you work a semester and then go to school a semester. So even as a student engineer studying for my bachelor's degree in electrical engineering, I was able to get practical experience working on some Air Force communications projects. But one of the things I learned in that experience was I really didn't want to work for the government. It's nothing bad about working for the government, but it just wasn't for me. And so when I graduated, my first job was as an instrumentation controls engineer working on petrochemical plants, which I thought was kind of challenging and interesting. And I did find that enjoyable for about the first 5 years, but I kind of got tired of doing the same thing. And that's when I went to my third and current employer, Southwest Research Institute, which is an applied research and development organization. It's very entrepreneurial and very broad, but I think our space science and some of our aerospace programs are some of our most well-known programs. But the nice thing about working at a research organization, you've always got different challenges, and so I've been able to work on a whole variety of aerospace and avionics types of programs, both military, commercial, and for NASA, working on planetary missions, supporting planetary missions or heliophysics missions, or even more recently, as we've been going to smaller satellite programs, some of the CubeSat programs, which are designed to bring space exploration into the universities and maybe beyond to allow opportunities for students to really participate in space research. So in glimpse, working with those types of programs, a very broad variety of programs, is sort of the nature of my job.
Thank you very much, Walt. I know that acronym NASA brings excitement when most folks hear it, and for you to be involved in NASA projects must be pretty amazing. Francesca, can you give us a glimpse into what you do?
Yeah, well, a very short answer to this question would be that I am a postdoctoral researcher at Sapienza University in Italy, and that I work in the field of radar systems, and in particular in the radar signal processing. But I actually received a very similar question a few months ago from my cousin, so I will, she's 15, and she asked me, she said, I mean, I know the title of your job, but what do you do exactly? I mean, you wake up in the morning, you go to your laboratory, and that was possible at the moment. Now you wake up in the morning, you open your laptop, and what do you do? So this question, because it gives us the opportunity also to say what is engineering research, in particular in our field, of course. So I like to say that we as researchers, we seek problems that need to be solved. And once we find one problem that catches our attention and catches our interest, well, of course, we do our best to address it by using the scientific method. So in particular, in our cases, what we do is we build our models to model the data that we assume to receive with our radar systems in a particular environment. Then our strategies can be to either detect a target, localize it, estimate its motion parameters, or get an image out of a scene, for instance, from the space. And then we validate our models and our strategies, we run our simulations, and then sometimes when it's possible, we get to do the most exciting thing, which is by trying and do the experimental trials. So we go to the field, we put the system in place, we collect our data, we add some targets. Sometimes it's a car, sometimes it's a drone, sometimes it's a person, so maybe we act as targets, and then we finally see if everything works as we expected at the beginning, or if we need to go back to the beginning and maybe change something in the model that we assumed and repeat the process. So as Walt said, it's everything. It's always a different thing, and it's a never-ending process because as researchers, we are never really completely satisfied. But that's very exciting. So I hope this gives a not so short glimpse into what we really do every day.
Thank you very much, Francesca. It was very interesting to hear what you're doing in researching radar. And I know that that's going to be something that's very interesting to our students and our teachers. Next, let me just scroll down a bit on the blog and share with you our next section, step 2 of the blog, and that is Discover. So the Discover section provides hands-on design challenges. So this is where you can really get involved and learn through designing different, materials, and using different materials, you can put together some really interesting designs and test those out. So in this month's issue, you can learn how to build a coffee can radar system. So Francesca, you might have to check that out and tell us what you think of that. Or launch your own straw or balloon rocket. So Walt, I don't know, NASA might be in trouble there because we've got some students who can put their own straw or balloon rocket together. And so let's see what activities are some of Walt and Francesca's favorites. So Francesca, can you let us know what activities might be interesting for you?
Well, first of all, let me say that all of them are very interesting, and it was quite difficult for me to choose one. So I actually chose 2. So as you said, as a radar person, I could not avoid mentioning the Build a Coffee Can radar by the MIT researcher David Schneider for IEEE Spectrum, where he basically shows that it is possible to build a very simple radar systems by simply employing 2 coffee cans as antennas, as radar antennas. And he actually shows that he is able to, with this very simple system, is able to measure the range and the velocity of a target, which is actually him running in front of the radar. But it can also be used to perform a very simple application of synthetic aperture radar, which is one of the most interesting applications of radars, because that's the one that you build to go to a satellite. You put on a satellite to get electromagnetic images of the Earth. So that's very exciting. And the second thing that was so close to the first one in my list was the article, the 20 inventions that we wouldn't have without space travel, because I must say that it was very interesting and I did not know a lot of them. And I was very surprised of seeing there, like the laptop that I'm using or the computer mouse that I have here. And so that was a very interesting reading for me.
Terrific. I agree with you. That was a very interesting reading for me as well. Learned quite a bit. So Walt, can you let us know what activities are most interesting to you?
Sure. So let me start out by saying, the first 2 sections are called Explore and Discover. And it's pretty ironic that NASA uses the terminology Explorer and Discovery as the 2 primary types of space science research missions. And so the activity that I chose in the Discover section here is actually related to a Discovery mission called Lucy that we're 1 year away from launch. The launch window opens on October 16th of 2021. And just last week, our mission team announced an opportunity to have the Lucy in Space mission and a competition. And the competition is designed for middle school and high school students. And it's on the TryEngineering site there. That for middle school students, they're challenged to develop a mission patch. The mission Lucy is to link astronomy and paleoanthropology. The Lucy term comes from the origins of the humanoid that was discovered several years ago, just how it led to the discovery of the origins of the human species. We're hoping that this mission to the Trojan asteroids will help us understand better the origins of the solar system. So the patch that middle school students would design would try to draw that type of connection between the origins of the solar system and the origins of the human species. Then for the high school students, the competition is directed toward messages that would actually go on the spacecraft itself, because the spacecraft is going to go into a permanent orbit around the two constellations of asteroids that are in the same orbit as Pluto, at what's called, I think, Jupiter. Jupiter, that we call the Lagrangian points. So it's possible that a million years from now, our species may recover that spacecraft, and we'd like to see what the students have put onto that communication for the future of humankind. So important to note for teachers out there that the competition, it will be judged in March. So if you want to have your students participate in this student project, plan it now in your into your plans for your students. And that's really the one that struck my attention, was the one. Thanks for adding that to the TryEngineering site, because it's a brand new student competition that I think the students will enjoy.
Thank you very much. As Walt mentioned, the resource and the link to that competition are on the TryEngineering website. It's also included in the resources for this webinar, and I'm very excited to pass that on to my niece, who's in 8th grade. So she'll be very excited to see if she can submit something for that competition. So next we'll go into part 3 of the blog, and let me just scroll down here so you can see. So step 3 is the Inspire section. And I'm going to pass things over to Donna, who's going to pick up with our interviewing.
Thanks so much, Lynn. Excellent. I'm so excited to be with the two of you, and this happens to be my favorite section, the Inspire section. And this section provides opportunities to make a difference. You can learn how to work on some real NASA science. You have to check out the Fireballs in the Sky project, where you can report sightings of fireballs to help NASA understand the early workings of the solar system. So what I'd like to do now is go back to Walt and Francesca and learn what inspires them. So Walt and Francesca, I'm going to have each of you share a story of how you were inspired to pursue this field. And Walt, why don't we begin with you?
Okay, thanks a lot. Well, you can judge from my age. I grew up, and when I was in high school and even elementary and middle school, was during the height of the first space race to put man on the moon. So the Mercury programs, the Gemini program, the Apollo programs were all underway while I was a public school student. And that was very inspiring to me. It's one of the things that really led to my interest in engineering, because a lot of engineering problems to solve in those first man programs. But I think one of the things that really gave my career a kickstart was, in those days, the National Science Foundation sponsored summer programs for high school students, typically between your junior and senior year in high school, where you could go and pursue STEM-type courses at various universities that participated in the program. I went to a 6-week math program at SMU, which is where I ultimately ended up going to get my bachelor's degree. And that was really a life-changing experience. And what it reminds me of is the TryEngineering Institute, where you have the 2-week programs for the high school students. So I really would encourage students out there to consider that TryEngineering program institute. It can really, really put your career on a fast track if you're interested in a career in science and technology.
Thank you so much, Walt. That's great. Yeah, you're not the first engineer that I've met that was inspired by those missions, those space missions, Apollo in particular. I've heard many engineers talk to that. So that's really, really cool. Thank you for sharing that. And yes, so happy that you mentioned the Summer Institute and having students consider learning more about STEM fields, about aerospace through various summer camps. And so thank you so much. That's great. Francesca, I'm going to ask you as well. What has inspired you?
Well, I must say that I actually remember the first time that I heard about radars. And this story goes way back in time for me to when I was a young little girl, because my dad is a now retired air traffic controller. And I was really fascinated when I was young. I was really fascinated by his job, and I was constantly asking him, what do you do and how do you do what you do? And he was, of course, trying to explain that to me in very simple words. And I remember the first time that he showed me a picture of a radar screen, which for me was quite strange, black and green screen. And he was saying that he was able to see aircraft that were so far away from him with that screen. And that, of course, caught my attention. And I remember that every time we went to an airport, he was like, yeah, look at this thing that is spinning around very fast. Well, that's a radar. This is what makes me do what I do. And I was really fascinated, really curious. I think that at that time, this thing involved a little bit of magic for me, because, you know, being able to see something that your eyes cannot see was quite strange. And I would have actually never thought that I would become a radar engineer. So I'm not 100% sure that that was the reason why I became a radar engineer. But I like to think that that curiosity somehow got stuck in my head. And then when the time came for me to decide what to study and what to do, I simply had to connect a few dots. So to the students that are listening, I would like to give you this advice: just be curious about everything you see, everything you hear, everything you read, and be faithful that that curiosity somehow will lead you somewhere in your future.
Oh, thank you so much. I love hearing about your story with your dad and the excitement about radar. That was almost magical, right? And same with the rocket launches, right? They're both magical. There's something really amazing about what engineers do, and that they can create these technologies. It's just so awesome. So thank you so much. I have some more questions under this Inspire section. Both Francesca and Walt, what ideas do you have for students to give back in their community? And this time I'm going to start with Francesca.
So I would say that there's plenty of things that students can do to give back to their community, and both from a local perspective and from a global perspective. So I'm going to say two things. The first one is one that I find really interesting, which is the Planet Hunter test program, which basically consists, you sign up to this Planet Hunter test program and you try and discover new planets outside of our solar system. The only thing that you basically need to do is to sign up, and then you get access to this NASA data from satellites that are observing bright stars. And what you need to do is to see if at some point, and to record it, of course, if there is a drop in light, because that could mean that a possible planet, passed in front of the bright star. So that could become a candidate planet, and then, of course, it would go through the entire validation process. But that could actually have a real impact on new discoveries. So I think more than 20,000 people are already involved in this project, volunteering for this project. But the number of bright stars that these satellites are observing is in the order of 200,000. So there's plenty of work to do. And especially in this moment where we do not go out very much and we spend most of the time in front of our computers, I think it's a great way to make an impact, to have an impact in our future. And the second thing that I would like to say is, either you get involved in this activity or in any other science activity, share it. Share it with your friends, share it with your colleagues, share it with your professors. Try to get your school or university involved in these projects, because the more we speak about science, I think that the more we realize that you say that science is not rocket science, right? It is actually reachable for everyone, and it may have a great impact on everybody's life. So that's my two suggestions.
Oh, thank you so much. Yeah, like we take the mystery away. And what I loved you sort of close with is that engineering, STEM is for everyone, right? Everyone can pursue this. So excellent. Thanks so much. And Walt, would you like to share as well?
Sure. My idea is somewhat similar. And looking at the citizen science site there, the program that really caught my attention was the Target Asteroids. And again, part of the reason was I'd already mentioned the Lucy mission, which is going after the Trojan asteroids around Jupiter. But I think the inspiration for the Target Asteroids program is the OSIRIS-REx mission. And it's kind of ironic because today is the day that the OSIRIS-REx mission is trying to collect a sample from the asteroid Bennu that they could ultimately try to return to Earth in 2 years from now. You know, the mission launched in 2016, got to the asteroid there in 2018, and it was quite different than what they expected it to be. It's essentially a rubble pile of rocks. And the collection mechanism they use, imagine a sort of a circular dustpan and that you're going to try to maybe blow particles from the surface of the asteroid into the collection pan and then return it to Earth. You can imagine the engineering challenges associated with something like that. As a result, just this last week, Southwest Research Institute, where I work, was able to conduct an experiment on a Blue Origin test flight, suborbital type test flight, on a collection device that we've termed the clockwork starfish. And if you can imagine a tetrahedron, sort of a spring-loaded tetrahedron, pretty small, but you could drop several of those on the planet. It's sort of inspired by the way a starfish, if you will, eats a prey larger than its mouth. It wraps itself around it and then folds it together. Well, this spring-loaded starfish mechanism would drop onto the surface of the asteroid and then spring shut and hopefully collect the sample and return it. But anyway, the asteroids are fascinating things. They explain the origin of our solar system, and there's many opportunities for students and amateur astronomers and amateur scientists to work with the data. You know, NASA makes all of this data available. It's very unique to have this data available to people, the citizens, if you will, to do all sorts of interesting science and technology from it. So I'd encourage everyone to check that out.
Wow, that was really neat. Thank you for sharing that. And yeah, both Francesca and Walt, you guys shared these opportunities to be collecting data, real data, for NASA through their citizen science project. So definitely check those out, everyone. They're quite amazing. Both that you have shared are really cool. So we definitely recommend that. And now I want to talk about the share section. And Francesca, you led me into this by talking about the importance of sharing, right? Of sharing and talking about science and engineering. And so we want you to do that with with these resources and all these opportunities that we're sharing today. We would love, love, love for you to use our hashtag TryEngineering Tuesday on social media. And if you can, we would so enjoy seeing what you're doing. We would love to see photos and any of the hands-on activities. Maybe you've done the balloon rocket. Maybe you've made that radar. That would be pretty cool for us to see. So please share if you can. We would love to engage with you and build this community. So thank you so much. I'm going to pass the ball back to Lynn.
Great. Thank you, Donna. And thank you to Francesca and Walt as well for being with us today and having such exciting responses to our questions. It was a really terrific interview. We really appreciate that. I'm going to launch into a live Q&A session here. Let me just take a look at our Q&A window. If you have any questions, please go ahead and type them in there, and we can get a roll on having some questions answered, especially since we've got Walt and Francesca with us, and they can answer some of these questions. They're live while we have them. So the first one I have here is for Walt. So Walt, you had mentioned you were inspired by Apollo. So if you were starting out today, what projects or aspects of aerospace would interest you the most?
I think the thing that's really changed since my time in the Apollo program is now space is available to commercial entities. This downsizing of the instruments and the computers and all that has reduced the size and the cost, if you will, of building space platforms to something that's truly manageable. And I'd mentioned the test flight of the Blue Origin last week, where we were testing out this concept for collecting an asteroid sample. I want to mention that another way that you can see that is that just also last week, Dr. Alan Stern was selected by NASA to be the first planetary scientist to fly aboard the Virgin Galactic mission to conduct a commercial flight to do scientific research. those of you that don't know Alan Stern, he was the principal investigator on the New Horizons mission, which went to the, we still call it Planet Pluto. It says, I'm saying it's a dwarf planet that arrived there back in July of 2015, and then went on into the Kuiper Belt of objects and arrived at the object in 2019. And he's now continued his research into other areas, and I think it's really exciting for him to be able to apply his aerospace engineering, his astrophysics and heliophysics background into commercial ventures. So again, to answer to the question, it's the opportunities are in commercial space flight ventures and the ability to conduct affordable space research and all the technologies that enable it, the computers, the sensors, those sorts of things. They're becoming within reach of something less than a government scale type of operation.
Great, thank you very much for that fantastic answer. I just learned so much from listening to both of you. So another question we've had come in is, and actually I think this could be both for Francesca and Walt, they're interested in finding out, and maybe it's not just one thing, but what one thing you like most about your job. So Francesca, I'm going to start with you.
I'm going to say that in general, I like that every day in some way we push the boundaries of knowledge a little bit further with our jobs. But I must say that if I have to pick an activity, I would like to say that the experimental trials are the data are the most funny part. The analyzing the data is, my favorite.
Great. And Walt, what do you like most about your job?
I like the variety. I would always encourage people to pursue doing interesting work. That's how I made some of my career decisions, and it always turned out to be the best to choose to do interesting things. But I think the single activity that I enjoy the most, maybe not surprisingly, is to actually go to a space launch. I've been to two of them, one on the West Coast out of Vandenberg, the Image satellite launch, which was our first mid-X mission, medium explorer mission, and then one on the East Coast out of Cape Kennedy, and that was the mission to the Juno mission. So it's very exciting to be able to go to space launch. These are really like rock star type events, electric atmosphere. And I guess I ought to mention that Lucy in Space program, the winners are going to be invited to go to the Lucy launch in October of 2021. You have to pay your own way to get there, but just getting an invitation to go to a launch like that is an experience you wouldn't want to miss. So if you need further encouragement to participate in the Lucy in Space competition, there it is.
That's exciting. I might have to look into that. So Francesca, we've got someone who's asking a question specific to you. They really enjoyed hearing your story about being inspired by your dad, and it helped inspire you to become a radar engineer. And when kids see aerospace from the outside, they might focus on, rockets or aircraft because that's what they see up front, but really don't see or understand radar. Do you have a way to explain radar to kids so that, they can grasp the concept?
Well, I think that a very nice way to explain radar is reported in the Discover section, and I was actually I wanted to mention also that one because the radar school for kids. It is actually, the way they explain with very simple words, with a few images, a few sketches. I think that's the best way to understand this very fascinating topic.
Great, thank you. So there's questions are bouncing back and forth between you, so it's just working out perfectly for me to manage. We've got a question for Walt. And Walt, that you mentioned a starfish-inspired design for the tetrahedral collection device. In what ways has the animal kingdom inspired your work specifically?
Oh, goodness, that's a tough question. Oh boy, you threw me a curveball there. I hadn't even. I think if you'd asked me to predict what the questions might be, I don't know if I'd have come up with that one. But I guess
an interesting one.
Most is robots and autonomy. That's an aspect of a lot of our activity at Southwest Research Institute, because what we're often trying to do with robots is take humans out of dangerous situations or repetitive and boring situations, and so consequently they have to be able to mimic or we have to essentially change how you do things from the way that humans did them. So you have to understand human operation very well. But some of when you go beyond stationary robots, you start looking at mobile robots, you start investigating the way different animals move, mobility. So you've got robots that are based on the way a snake moves. You've got robots that are based on the way perhaps a horse or a mule or donkey might move. And you have to study those and look and see if you can apply those, as well as some of the behaviors. So I guess, again, just when you look at autonomy and robotics, that's where you might get some of your best inspiration from the animal kingdom.
Great. I'm really impressed. You picked up that answer really quickly, despite the fact that the question was a little bit of a challenge. So thank you.
Yeah, we like tough problems.
Well, on that note, you had both mentioned what you liked most about your jobs. What do you find the most challenging part of your job? Francesca, I'll start with you.
The most challenging part, I think, is to, that's a tough question, yeah. I would like to say that that's the modeling part of what we see. I like to think as a radar as a way of seeing something that your eyes cannot see. So you try to model what this system is able to see, and that's, I think, that's the most challenging part, but yeah, also very, very interesting one.
Great. And Walt, what are you challenging?
Okay, so the organization I work for, it does contract research for clients in government and industry. So we're getting paid. We're not just doing research for research's sake. We're doing research to essentially take new discoveries, develop technology from those discoveries, and use them to solve technical problems. And when you do that, we're doing it on a contract basis, just like a for-profit type company would do. And so the most challenging thing is what we call the triple constraint, where you need to be able to meet the technical requirements of the project that you're trying, or the problem you're trying to solve. You need to do it within the schedule that you promised, because whether it's if you're trying to meet a launch date, that launch date may not change. If Pluto, for example, only comes into approachable orbit once every few hundred years, right? So the schedule's important, equally important, basically, and the cost. I mean, there's not an infinite amount of money available to solve these problems. Technically trained people like to, there's sort of a joke saying at some point in the project you have to fire all the engineers, because they would continue to refine it indefinitely if they had the budget and time to do so. So the challenge is meeting all those constraints, and it's important whether you're working on a government program like a space launch or a commercial program where you're trying to bring a new product to the marketplace, because time is money, and those clients are definitely acting like they're spending their own money. So that's what I find the most challenging in general.
Great. Thank you both for answering that challenging question about your challenges. So I'm going to give you a break for a second, because I do have some questions that have come in that I can answer. One is, how often does the TryEngineering Tuesday blog come out? Well, that comes out once a month on the third Tuesday of each month. So today is the third Tuesday in October. That is why we're putting out this month's issue, as well as having today's webinar. So each month when we put these issues out on the third Tuesday, we do try to accompany it with a webinar where our guest presenters will match the topic for that particular month of the blog. So you can look for some information about our next one that will be held on November 17th. And then someone is asking about where can they find the blog when they go onto the TryEngineering website. So you can find it the quickest way, I think, is on the home page under the What's New. And you can see there's a little card there for this month's issue of the blog. And you'll also see a card there, maybe a few cards down, for last month's issue, and that was on ocean engineering. So those are our first 2 issues of the blog, and you'll find lots of great resources there. And again, please share back anything that you've used. I'm going to put one more question out there. It looks like, I think that might be our last one for today. So Walt, I'll start with you, but this is going to be the same question for you and Francesca. Someone's asking, they're interested in getting involved in aerospace engineering and going to the university for it. So what types of degrees would you recommend for someone that wants to work in your specific field?
So I'll jump in and say, of course, electrical engineering and computer science, but also aeronautical or aerospace engineering, mechanical engineering, virtually all the engineering disciplines. There's materials problems. One of the current areas is hypervelocity space vehicles, and then so you have tremendous material problems. So think of all the physical sciences and engineering disciplines, but I mentioned, I think, the primary ones.
Great. Francesca, do you have any specific degrees that would be useful?
Yeah, I would say the same. The most the best part of this is that it is a multidisciplinary topic. So we really need everyone. Expertise is very different expertise. And I studied telecommunication engineering. I work with aerospace engineers, and so yeah, I perfectly agree with Walt.
Terrific. Well, that wraps up our questions. We had some really great ones come in today, and of course, some really terrific responses to those questions. So thank you both for that. I'm going to go ahead and wrap up today's session. So again, reminder, be sure to share what you've learned about aerospace engineering as you're using the blog and as you listen to today's interviews. Using hashtag TryEngineering Tuesday. We really want to hear from you. And we also want to hear about how you're using the blog and how you're using the resources. And if there's resources that you would like to see, but you're not seeing them there, let us know that too, because we have to have that continual feedback to build the resources that work best for you. So we cannot thank you enough, Francesca and Walt, for joining us today. This was a fabulous session. Really, really enjoyed hearing your stories, your personal stories about what you do every day. So thank you very much for joining us.
Appreciate it. Let me just put in a plug for the Aerospace and Electronic Systems Society. Remember, professional societies are very important. They're the groups that put together the peer-reviewed publications. They organize technical conferences. They develop the standards. So if you want to be someone who's anyone in these fields, get active in your professional society.
Thank you very much, Walt. That's fantastic. And each blog that we do is going to be tied to one of our IEEE societies like AESS, so you're going to get a really great introduction to IEEE societies. So thank you all. Have a great day.
Thank you. Thank you. Thanks so much. And thanks, everyone, for joining. We really appreciate you coming in and checking out this virtual event. As noted earlier, the on-demand link for today's event will be emailed to all registrants in approximately 2 hours. Before you leave, don't forget to complete our feedback survey via the teal survey tool at the bottom of your screen. Also, don't forget to register for upcoming events in the resources section, including this Thursday's Engineer Spotlight with Hal Walker at 3 p.m. Eastern Daylight Time. Thank you all and have a great day.